Hey guys, welcome back to the channel. Today's video is going to elaborate on the weird behavior we saw in Red Dead Redemption 2 in the last video. Specifically, I found a fix and can show you how to go from these non-FSR results where I couldn't run more than one test without crashing or even complete an ultra run at all, to these results where I was able to run them all back to back with no crashes, completed on ultra, and almost double the average FPS, all without FSR. The best part? The fix is simple, reversible, free, and will likely cause many more memory-heavy games to run better, or at all, on the Steam Deck. Let's get started. So let's recap the issue really quickly. In the last video, I found that Red Dead Redemption 2 had a memory leak that caused crashes after about 10 or 15 minutes from game launch every time on the deck, including crashes that made me restart the deck itself. Since the last video, I dug into the issue, and thanks to Reddit user AncientGrand46's work, we have some really great results. Let's walk through the process, why it works, and then we can compare pre- and post-fix results. Note that I'm not responsible for any harm that may come to your Steam Deck, although the process has been tried and true on Linux systems in general for many years. The first step is to get into desktop mode. This process will require running commands in the terminal, but they're simple. As always, a keyboard helps, but I've done many commands using only the on-screen keyboard as well. Secondly, we have to open up console, or the terminal app. You can do this by going through the start menu and going to the system section. Third, we need to set a password for our user on the deck if you haven't already. This is done with the passwd command, then typing in your desired password, pressing the enter key, typing in the same password again, and then pressing enter one last time. Fourth, we have to temporarily disable the read-only file system on your deck. While the original post omits re-enabling it, we will be later for safety. To disable the read-only file system, just run sudo steamos-read-only disable and enter your password when asked. Fifth, we have to navigate to the root of the home partition. To do that, just type cd/home. Sixth, we have to temporarily disable our old swap file system so we can expand it. That's done with this command, sudo swap-off-a. Seventh, and this is the most dangerous step, so be very sure that you type it in correctly, sudo ddif /dev/0 of swap file bs 1g count either 8 or 16. The dd command is notorious for causing people pain from typos, so again, be very sure that you've typed it properly. Note that while the original post mentions to use count 8 here, I chose to use 16. We'll get into why in a little bit, but the only thing that will change is the amount of gigabytes in your swap and how much storage it uses on your OS drive. If you have very little storage left or a 64 gigabyte Steam Deck, you may want to use 8 instead, but I opted for 16 as I have the 512 gigabyte model. Eighth, we have to tell the OS that the swap file is valid with the command sudo mkswap swap file. Ninth, and we're almost done, we run sudo swap-on swap file to actually start using the newly expanded file. The 10th and final step is to re-enable the read-only file system. We can do this by running sudo steamos-read-only enable. And that's it. We can confirm that it worked by running the free-g command and seeing that there is a 16 or 8 gigabyte swap depending on which option you chose. If something went wrong, just repeat the steps and double check both spellings and that you're using the same casing on your characters. A lowercase a does not equal an uppercase A when using Linux. Okay, so let's briefly touch on what a swap file, or swap, even is. In essence, it uses your disk as overflow for stuff that won't fit in your normal RAM. It's far slower than real RAM, so usually you'd either never use swap or avoid its use as much as possible. The difference here is that we're gaming on an integrated GPU. Integrated GPUs don't have their own dedicated VRAM, so they share with the CPU. I believe this is why there's a 1GB swap file already present on the deck. Valve sets the GPU to use 1GB of memory, so they make up for that missing 1GB by giving you a 1GB swap file. By setting the swap file higher, we can give the deck more memory to work with, even if it is slow. This might be detrimental to memory performance, but it's better than crashing and might actually improve game performance in some games that use RAM aggressively. Now that we've done the fix, let's look at Red Dead results in more detail, starting with the memory graphs from the last video. Here, we can see that memory kept creeping up and up. I can confirm that it tends to crash between 14.5 and 15 gigabytes of used RAM, but I couldn't get the log output for those runs since the whole deck crashes. Now, let's look at memory usage with the fix in place. Here, you can see that memory usage actually spikes up more quickly, but then it evens out and maintains just shy of 14 gigabytes used. It seems that by giving Red Dead more memory to work with, it becomes more stable despite using basically the same amount. Now that we've confirmed that Red Dead won't crash and why it won't crash, let's look at the actual performance, starting with the low preset and no FSR. As you can see, the 0.1% low and 97th percentile results are wildly different, but I can confirm that they happen during loading screens, so let's ignore those for now. The average FPS here is 63% better with the fix than without. Next, we'll look at the top end of what I was able to run prior to the fix, the high preset. In another win, we can see that we get a 62% boost in performance, but without a crash immediately after the benchmark. Lastly, let's see if FSR is worth it at all with this new fix. Nope, we actually lose performance with FSR for some reason. Looking into the available data, I can see that the GPU is working harder with FSR enabled, so for now, we'll have to assume that Rockstar's implementation of FSR is either bugged or inefficient. Alright guys, that's all for this shorter video. I just wanted to show you the awesome fix and how it can resolve the one issue I've found with a game on the Steam Deck so far. The next video will be benchmarking a new series of games, so be sure to like and subscribe for more technical Steam Deck content. See you then!